Hello everybody, I am Sarvesh. As you know, I am studying grade 10 batch 4 in HKS International School. Today I am here to explain about electrical circuit. In electrical circuit, I have used simple circuit, Ohm's law verification, series and parallel. All four I have used in a single working model. Let us see how it works and I will explain what and all required materials and how it works. Let us see by watching the video and let me explain you each points. Welcome to electricity chapter. This is my model which I am presenting here. Electric materials required. Electrical materials required. LED lights, I have used LED lights. Battery. Two-way switch, I have used two-way switch for the controlling of the working model. Switch, I have used switch for simple circuit. Wire, I have used 1 meter of wire for this working model. Buzzer, I have used buzzer for simple circuit. Multimeter, I have used multimeter for checking the resistance. I am going to explain simple circuit now. This is my simple circuit. I have used switch, battery and a buzzer.
What is electric current?
Electric current is nothing but simple circuit. Let us see what is electric current before knowing simple circuit.
Consider a simple circuit connected with a cell, plug key and a bulb in series with an ammeter
Here,
to measure
battery,
the current.
bulb, plug key and ammeter. Plug key nothing but switch.
Insert the plug key and observe the flow of current. We can see that there is an electric current flowing in the circuit which turns
If we
on the
switch
bulb.
on the switch, we can see
The
that
charges are
the electric current
separate
passing
which
through
set
the
up
wire.
electric current in the circuit.
How we recognize means bulb is glowing now. So we are recognizing that bulb electric current is
electric
flowing
current
through
is
the
considered to be the
circuit.
flow of positive charges.
You can see here.
The direction of flow of positive charges was taken to be the direction of electric current, which is opposite to the direction of the flow of electrons. If a net charge Q flows across any cross-section of a conductor in time t, then the current I through the cross-section is I equals to Q by T. The SI unit of electric charge is Coulomb, which is equivalent to the charge contained in nearly 6 into 10 to the power 18 electrons. The electric current is expressed by a unit called ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per second.
Now, electric current is the rate of flow of electric charge. I equal Q by T. And now, what is Q value you may be thinking? The Q value will be equal to 6 multiplied by 10 power 18 electron charge. 6 power 10, 6 into 10 power 18 electron charge will be the Q ratio or a value. The electric current is the expressed by the unit of ampere. The electric current expressed by a unit of ampere. Here they are telling that electric current is expressed or a monitor or a unit of the ampere. Here 1 ampere is equal to 1 coulomb by seconds. Coulomb is nothing but electric current. Coulomb is nothing but current. Here 1 ampere is equal to 1 coulomb by 1 second for the electric current.
An instrument called ammeter measures electric current in a circuit. It is always
Here they are telling that an instrument called an ammeter. So instead of ammeter I have used multimeter for checking all the resistance or current flowing through the wire. Instead of taking our expansible multimeter or ammeter or voltmeter, we can take the multimeter. It requires all the voltage. We can check in this voltage amps, milliamps, ohms, we can check all the resistors. So instead of taking that, I have taken a multimeter for checking the current flowing through it. Here in this circuit, the current of milliampere is 75. Milliampere is taken as 75 here, and
is connected in series in a circuit through which the current is to be measured.
next is Ohm's law. Before knowing of Ohm's law, let us see our working model. Come on. See, this is my working model. I have used a simple circuit here. For a simple circuit, the requirement materials are a battery, a single way switch, buzzer, and a two-way switch. You may ask, why is two-way switch is required? Two-way switch is required just for controlling all the auxiliaries. So before owning the buzzer or a simple circuit, we should be controlled with a circuit, a two-way switch. I have on now, two-way switch is on, and now I am going to on the simple circuit. Let us see how it works. If the buzzer blows or makes sound, we know that the battery is passing the current through the wire, and wire is passing the current for a buzzer, and this all circuit is controlled, this simple circuit is controlled by a switch. So here I am going to on the switch. Let us see whether current is passing through the wire or not. Come on. Yes, the current is flowing through the wire. I have recognized because the buzzer is making a sound or noise. So I am recognizing that the battery is passing the current through the wire. So let us switch off this. This is all about simple circuit. It's a easy circuit and a simple circuit. So they have named as simple circuit. Everyone can make this circuit, simple circuit. It's dead easy to make and so easy than other circuits to make. Next we can see Ohm's law. Let Ohm's law. What Ohm's law is verifying, let us see. So come on. For Ohm's law I have used a battery, switch, instead of resistor I have used
across a conductor
a bulb.
and current through it in an electrical circuit. We have taken a conductor made up of nichrome wire in the form of a coil. It is connected.
Here there is a battery for Ohm's law, and there is a plug key, milliampere, voltmeter, and a nichrome wire as a coil they have taken. They have taken as a coil as a nichrome wire. So this circuit is known as Ohm's law verification. This Ohm's law verification, let me see how. Here Ohm's law verification is also placed a graphical standard. In this video only we will see how to plot a graph, in which we should plot a graph, and in which variables we should take to plot a graph. Let me see in this video. Come on.
To the circuit as shown. Since we have to find the potential difference across this conductor,
We want to find the potential difference of this circuit.
To find the current flowing through the conductor, an ammeter is connected in series with it. A cell
Ammeter is connected in a series.
The circuit. Close the circuit by inserting.
I told that plug key is nothing but a switch.
Current starts to flow through the circuit.
If we plug on,
The
current
voltmeter is
starts
showing
to
the
flow
potential
on
difference
this
across the
circuit.
nichrome wire as 1.5 volt, and the ammeter.
Here, ratio of V by A. If we want to find R, the R value, R is equal to V by I. If we want to find a V is nothing but voltage. If we want to find a voltage, I by R. If we want to find I value, nothing but a current. If you want to find a current, I is equal to R into V, R by V. So they have given here a voltmeter and milliammeter, ammeter and milliamps, ampere. Voltage. Now first take a V. We want to find a R. So we are taking V by I. Here V is 1.5. 1.5. So V by I. V we have taken as 1.5 here. And here ampere 75. So we want to calculate with 0.075. It's nothing but if we substitute this value, we will get 20. So by taking this only, we should plot the graph. Let me see how we should plot the graph.
Is showing the current flowing through it as 75.
Now the current flowing through it.
Mark this point in the V versus I graph.
Mark the point on V by I. See, you can see here, they are marking the V and I. If we use two batteries, what will be the volt and ampere?
Of potential difference across.
Here we have used a single battery. For this we have used a dual battery. For dual battery, what will be the volt? For dual battery, there will be a 3 volts. For milliamps, 150. 150 is nothing but 0.15 also. V by I is equal to 3.0. Why we have taken 3.0? 3.0 because voltage is 3. We should take it is as decimals. So we have taken it 3.0. And 150 as milliamp I current. So we have taken as 0.15. So if we substitute this also, we will get the value same, but no difference in the value of 20. Flowing of current is divided and substituted to get 20. And now in this graph they will show how this point is being marked in the graph. Let us see. Come.
Across the nichrome wire, an ammeter shows 150 milliampere current flowing through it. Mark this point again in the graph.
See now here. They have marked again in the graph.
Similarly,
it is
add a
right.
third and fourth cell in the circuit and mark the respective points in the graph.
See. This is single battery. This one is dual battery. This one we have used 3 batteries. For this we have used 4 batteries. 4 batteries, nothing but 4 cells. 4 batteries, nothing but 4 cells. If we take the 4 values of V and I, we will get same R. R is nothing but resistance. We will get same resistance. So all this V by I should be marked in a graph. If we mark for Ohm's law verification, if it is a straight line from the graph, it's called Ohm's law verification. And here you can see here the coil is burning, because I'll say the reason in this working model. Why the coil is burning, I'll say in this working model. Come on, let's watch more and let's come to my working model.
We can see that the V versus I graph is a straight line passing through the origin. The ratio of V and I in each case is the same. Thus, V by I is a constant ratio.
And here they are telling that V by I, it's a constant ratio. Constant ratio. So we are getting all the values are equal 20, 20, 20, 20.
Ohm's law is derived from this observation, and it is defined as the potential difference V across the ends of a given metallic wire in an electrical circuit is directly proportional to the current I flowing through it, provided its temperature remains the same. constant called R. R is a constant given for a metallic wire at a given temperature and is called resistance. The SI unit of R is ohm.
Here, what is Ohm's law? A derived version or a verified answer of the Ohm's law. Ohm's law is defined as the potential difference V across the end of a given metallic wire in an electrical circuit is directly proportional to the current I flowing through it, provides its temperature remains the same. It's a definition of Ohm's law verification. V is nothing but voltage, I is nothing but current. So here they are saying that V is directly proportional to I is directly proportional to V, and V by I is equal to a constant. They both are the constant R. R we name it as resistance. R is nothing but resistance. And you may think, what is the SI unit of R? R is nothing but resistance. What is the SI unit of resistance? Resistance is ohms. So they have named it as Ohm's law. This is about Ohm's law. I told before before the video, the coil was burning. Let me say why. The reason in my working model. Come on. This is Ohm's law verification. For Ohm's law verification, I have used two-way switch, battery, and a LED light. Now I will on the switch. Don't be shocked, it will be not working. I will say the reason why it is not working. Let me on. You may see it's blinking. You are seeing, no? It's blinking. Let me say why. The battery consists of 9 volts. The LED light consists of 3 volts. All this 9 volts power gets into the 3 volts. So this 3 volts this 3 volts LED light cannot consist 9 voltage of current. So it has been burned. It has been short circuit. So you are seeing that it has not working. It's blinking, slight blinking. That's it. Why? Because it doesn't consist of 9 volts of the battery. It just consists of 3 volts. That's it. If we pressure on a light by using more power of the battery, it will get burned or short circuited. And you may ask in next question how these circuits are working. I'll say for that also. Come on, let's see what is series circuit now. Let us see what is series circuit. Now I am going to tell about series circuit. This is my series circuit. Instead of resistance, I have used here LED
When
bulb.
resistors are connected in series, what happens to the value of the voltage across each resistor and current through them? Let's find out through this activity. We have connected 3 resistors in series to the circuit having an
Here they are connected with the 3 resistor. R1 we can name it as R1, R2, R3, and a plug key. Plug key is nothing but a switch, and a battery. Battery is nothing but cell, and a voltmeter, and a milliampere, and a wires. Let us see.
ammeter and a voltmeter across all 3 resistors.
Voltmeter is connected
All
parallelly
3
for the
resistors of
series.
different values, we can see that the total current flow
If we
through the
switch
circuit
on
is
this
50
circuit,
milliampere,
we can
and the
see
voltage across them is 3 volt.
voltage across them are 3 volts
Each resistor
and
by placing
50
voltmeters
milliamps.
we can see that voltage across each resistor.
We can see that for total circuit we got only the 3 volts. Why you are getting the 0.5, 1 and 3, 1.5? If we consist a single register R1, we will get just 0.5, or it may come 1 or 0.5 or 1.5. But if we consist a single place of this, we will get point values or 1 or 0.000 something may come. Let us watch more detail about this.
Is different. When we closely observe it, we can see that the total voltage across the series of resistors is equal to the sum of voltages across each resistor. Now, let's check the amount of current flowing through each resistor by connecting ammeters through each of them. We can see that the value of...
Now, before we have been connected a voltmeter, now we are connected with an ammeter. These are called ammeters. Voltmeter was showing the different values for a resistance. R1, R2, R3 were different. But in ammeter, flow of current is same and equal in all resistance. R1, R2 and R3 are equally passed current.
all ammeters is same. This implies that in a series combination of resistors, same amount of current flows through each resistor. Vary the resistance of all three resistors and cross-verify. Thus, we find that when resistors are connected in series, the current through each resistor is same and the voltage across them is different, which depends upon the resistance of each resistor.
Here, they have told what is resistor in series. Now I am going to show my working model, how it works, and I told before Ohm's law, how is this LED bulbs are working and how this LED glows, why it doesn't burn, and I will show now and I will tell you now. This is all about series circuit. For making a series circuit, I have used a 3 LED bulbs and a battery. For this controlling auxiliary, I have taken a two-way switch. You may ask me that how these bulbs are glowing now, why this doesn't glow. I told before this is 9 volt battery, this is 3 volts. It consists of 3 volts. So 9 multiplied by 3 times. 3 multiplied by 3 times is 9. So 3 into 3 into 3. We are getting 9. We are getting 9 volts. But the battery is less than 9 volts. It's not assured properly and correctly as 9 volts. Let me on the series circuit. You see how it works. This is series circuit. You may see the battery is passing the current through the wires and it has been connected to the two-way switch, and this two-way switch is connected to another two-way switch for controlling this series circuit and parallel circuit. I have told 3, 3, 3, 9. So it is these lights are glowing. To check the voltage ammeter in the single part of the R1 and R2 and R3, and we can also connect with the R3. Before checking in the meter, we should check whether the voltmeter or a multimeter is in the connective. So it is in the connective. So let me check how much current is passing through this circuit now at present. Positive every time will be in right hand side, negative will be in left hand side. So I have taken a negative wire and I am placing on this, and a positive I am placing on this. You are seeing that the ratio or the point of this or the current flowing through this circuit is the value we can 6 or 3. Just I have got 3 here. I have got 3 in this multimeter. What is the current passing through it? In this series, I have got 3. Let me check for each R1, R2 and R3. For R1, I am keeping a negative wire on here, positive and here. I am getting here 1.5. I am getting for this R1 I am getting 1.5. Let me check for R2. R2 I am getting 0.5. So let me check last but not the least for R3. Negative in left hand side, positive in right hand side. I am getting 1.5. In this we are knowing 0.5, 1.5 and 1 is equal to 3. The total circuit current is 3. We got for all resistance is 3. This is all about series circuit. This recognizes that R1, R2, R3. For calculating this R1 and R2 and R3, how to calculate in series? For series, we need to calculate series is equal to R1 plus R2 plus R3 is equal to this value. It's nothing but R1 plus of R2 plus of R3. Now I'll switch it off this and let me see what is parallel circuit. Resistors in parallel. You are seeing in the pic is an Albert Einstein. Let me show you resistors in parallel. This is all resistors in parallel. For parallel circuit, one by one should be there.
Parallel. What happens to the value of the voltage across each resistor and current through each of them? Let's find out through this activity. We have 3 resistors connected parallelly in the circuit with an ammeter.
We have 3 resistors connected with the parallel. I have connected in a parallel LED lights.
That the total current flowing through the circuit is 550 milliampere.
In this circuit, they have used 2 cell wires, milliammeter, voltmeter, resistance and plug key. Plug key is nothing but a switch. Don't be confused in an examination that plug key is named means it's nothing but a switch. In this circuit, I have plugged this circuit. In this circuit, they are showing in parallel. For a parallel circuit, we are getting the voltage as 3 and milliammeter as 550, and this 550 will be read as 5.50 also. Let us check now.
And the voltage across them is 3 volt. Let's check the current through each resistor by placing the ammeters. We can see that all of the current values are different across.
Now, we are checking in this circuit that by placing an ammeter for all these 3 resistance, we are getting different values. If we add these 3 resistance, we will get 550. 300 plus 100, 400. 400 plus 150, 550. So you are getting 550. If we calculate one by one, same. If we calculate total circuit, we will get 550 only. Let us see how and the process is going here.
As each resistor. When we closely observe it, we can see that the total current through the parallel combination of resistors is equal to the sum of currents through each resistor. Now, let's check the amount of voltage across each resistor by connecting voltmeter across each of them. We can see that the value of all voltmeters is the same. This implies that in a parallel...
You have seen here. If we place an ammeter for all these, there will be a different value, but for total we will get 550. Here if we place a voltmeter, we are getting the same resistance 333. For each we are passing 333 volts. Why? Because the battery consists of 9 voltage. The battery consists of 9 voltage. So we are taken 333 for a resistance. Let me see. Come on.
Combination of resistors. The voltage is the same across every resistor. Vary the resistance of all three resistors and cross-verify. Thus, we find that when resistors are connected in parallel, the voltage across each resistor is same and the current through each will be different, which depends upon the resistance of each resistor.
Here, for a parallel circuit, we are seeing here, when our resistors are connected in a parallel, the voltage across each resistance is same and the current through each will be different, which depends upon the resistance of the each resistors. I have shown before this video each resistance are different but each voltage same. So to total resistance to be calculated in 1 by R is equal to 1 by R1 plus of 1 by R2 plus of R3. This is the calculation method. This is the calculation method. Now let us see our model, our working model, how the parallel circuit is working. See, now in a parallel circuit, to glow a parallel circuit, I have used a battery, two-way switch and 3 LED bulbs. For this also implies same 3 into 3 into 3 is 9 volt. Let me switch on the parallel circuit and let me explain. You can see here the parallel circuit are glowing. To parallel circuit calculation is 1 by R1 plus of 1 by R2 plus of 1 by R3. To check how much voltage and ammeter is running in this circuit are positive every time in right hand side, negative every time in left hand side. Place the positive in right hand side and negative in left hand side. Oh God, now I am getting 300, but we saw the experiment of the television, in the television 550. I am getting 300 milliamps. I am getting 300. Let us check how much will be there in R1, R2 and R3. R1, I am getting, just a minute, let me recheck once. Oh no, I am getting 350. I am getting 350. To check this all R1 and R2 and R3, R1 100, R2 150, R3 100. If we calculate 100, 150 and 100, 350 we are getting for a parallel circuit. We are getting 350 for a parallel circuit. Now I am turning off these LED lights and now I am continuing the video. Thank you for watching this video, for your patient listening.